both actually up and moving. Okay, remember 6th grade, they do better up and moving than they do computer simulation, but we do have a couple computer simulations coming up soon. So let's just get going here. Okay, so air traffic control. We've all learned this already, so I'm not going to go into details, but basically you have all the air traffic control centers. We have the towers at the airports themselves. We use radar. We use a couple different kinds of systems to track the aircraft. They get out the ground, they get up en route, and they fly. What's the most important thing that happens when they're up in the air? That they don't run into each other. So air traffic controllers help keep that separation, and they help to ensure that the aircraft gets where they want to go on time, safely, happy customers, good flights without wasting too much fuel, and to maximize time. So there are a lot of aircraft travel. Every aircraft that is flying through the sky right now has to maintain a current route. So if you just picture this overlay, this point right here would be about down here in California, so LA. And so this is a typical route that an aircraft would fly. It has to go from dot to dot on the route. Okay? They don't have the choice to really vary off that route unless there's a conflict and they have to be moved momentarily. Then they will get back on the route eventually. Here's the number of routes that are currently used across the United States right now. Routes going every which direction, as you can see. Some very, very busy areas in the sky. Then we go into a computer simulation using smart skies. We all got a chance to do this a couple days ago, so I'm not going to pull the simulation up. But you saw how we were able to control the speed and the route of the aircraft to avoid any conflict. So that would be one of our computer-based simulations. Okay, and now it's our turn to fly. Aircraft activity. This is where Rob and Margaret are going to come help me out. Okay, this is an activity that would be using people to create an air traffic simulation. Come around here, please. So what we would do in the classroom is we would have spots marked out on the floor, very, very similar to how we saw the Smart Skies simulation. How each mark represents so many nautical miles. And so the aircraft would have to maintain a certain separation distance to maintain safe air travel. And so just like in the simulation, we would have students work together in groups of 3. And so in this scenario, I'm going to say John is flying on his own. So John, come on over here. And then you two are going to be right over here. Margaret, you can stand right by the table. Rob will be in the aircraft. Okay, so in this situation, I'm going to represent the air traffic. Okay, so slide over. Slide over. Over against the desk there. Okay, there we go. All right, now, the route in this situation.
Okay, 6th grade.
John's going to fly straight down here until he gets to Linda. Then he's going to come over here and turn into Myron, and then continue on to Pat. Okay, Rob's going to fly over here to Margaret, and then turn and fly into Myron, and then continue on to Pat. Now, the issue is they're both flying at the same speed in the same route, and they're going to have a conflict at some point. So, aircraft begin. Now, I'm the air traffic controller. 1 step per second, gentlemen. Okay. Sorry, forgot to mention that part. And of course, kids always laugh at you when you don't give them all the directions. So you're going to walk 1 step per second. Of course, I would have a stopwatch and actually timing this. And so as they move, what I'm going to do is, as an air traffic controller, I'm going to recognize that they're going to have a conflict at some point. And so I'm going to call the pilot, which is Margaret, and tell her that there's going to be a conflict, and I would like her to slow her aircraft down. Or speed up. Okay, so she's going to respond back to me that she heard me, and she's going to slow her aircraft down so that John will be able to pass safely to the destination, which is Myron, and then continue on towards Pat, and then Rob will slow down so that they do not collide and maintain that separation. Okay, ready? Begin. Sure, that's fine. Control to RF 1465. Please slow down your pace to 1 step per every half a second. I mean, every 2 seconds. Just tell him or just tell him.
There you go.
Okay, so that worked. It worked in an unpracticed sort of way. Thanks, guys.
Thank you.
All right, so, okay, kids are going to love this kind of activity because it gets them out of their seats, it gets them moving. They can actually get up and practice some air traffic control simulation and activities, and they'll have fun with it. Some of their buddies might try to collide them into each other as a fun thing. That's okay. We would have some free time for them to create their own simulations, just like we saw in Smart Skies. But they're also going to have a couple of structured activities that they have to run through, and they will actually have to calculate the speed and the trajectory to make sure that there is no conflict. Okay. So, in summary, we covered the history of aviation, which again is important because as sixth graders, they don't have a lot of background knowledge on the subject. Okay, so it's for them to actually visualize, to be able to see all those gliders is very important to be able to connect the parts, the controls, the pieces of the airplane, how it moves, how it interacts with the forces, and so on. We explained the forces and the components. We discussed the design process, which again can be applied to so many things in life, scientific, mathematic, everything else. The design process is very, very important. We talked about the air management systems, and again, running these simulations, both on the computer and in the people activity, the simulation. We would discuss, of course, our researchers' model of using the corridors versus not using the corridors, and a mixture of different things. So in this situation, John would have represented the aircraft that was flying in the corridor because I didn't have to communicate with him. He was on a set track, and I could just let him fly through my sector. Okay, so we can have different situations like that. We can run different simulations with that. So in closing, we have a couple of activities and games. Again, we use the Kia website, which allows us to create our own activities. They can be anything from like a Jeopardy game to, what are some other examples? Vocabulary. Yeah, Rags to Riches, which is kind of like a Who Wants to Be a Millionaire type of a game. We do a lot of our tests online, which the kids really enjoy. Because they're able to take their test online, they're able to pause their test if they don't finish it within a class period, so that relieves the anxiety, the stress of trying to cram it, get it done quickly, which I'm feeling right now because I'm getting close to my time. And so they can pause it, they can go home, they can finish it. We can set the parameters so they can retake the test if they didn't do very well, which is a learning tool because they have to go back and reread, restudy, and then they can retake to improve their grade. You want to just show a real quick example?
This year is we sign up and we have profiles, and this is my profile that I was able to get a couple activities in place along with a quiz dealing with flight and air traffic and so forth. This year is the first two here. The activities are for review. We could use them on the day before exam or assessment. And it brings up different things here. Again, this is if you're schooled a lot of sight, you can easily have this year-round. You use this every unit, as you might say.
Okay, so yeah, this is a multimedia way to review. It's fun, the kids love it. It's great for tests. Again, multimedia with the test. We can do video clips, we can do pictures, we can do all kinds of stuff. So in closing, we have the national standards. We've got our national standards. We've got our Minnesota State standards, which obviously are crammed together because there's a lot of them. We've got our resources and things. We've got several different physical activities, physical get up and move type activities. We've got a couple of computer simulated activities, and we've got other worksheets and things that go along with this. They'll take notes and record data as they construct their aircraft and everything else that's involved with it. There'll be informal assessments, participation, collaboration, all kinds of quizzes, mini quizzes. Of course, we circulate the room and are involved with all the design processes and the testing processes. Next steps, we are going to obviously use this in our classrooms as well as the other sixth grade classrooms in the middle school, share it with the other grade levels above and below, and if they need to adapt it and they can use it themselves, that would be wonderful.
As well as cross-curricular, we can bring in social studies.
Yep, absolutely. ModSim, we can apply that ourselves as often as we would like because we've got the access to the computer lab. Also through professional development opportunities and things, we can share that with other teachers, hopefully encourage them that this model of learning is hands-on, it's great, it's fun, and very effective. Our schools will be encouraged to introduce more lessons through our demonstrations, as well as teacher collaboration when we work together cross-curricularly or within our department. That's it. You ready to go? Ladies and gentlemen, today we are starting a brand new unit, and we are going to be learning about the aviation dynamics and engineering, beginning with the history of flight. You just witnessed some incredible aeronautic acrobatics, and these are capable in newer airplanes, newer aircraft, but that was not always the case. Before we begin, let us introduce ourselves.
I'm John Kuznik. I teach 6th grade science at Willmar Middle School in Willmar, Minnesota.
Ben Panchyshyn, co-teacher with John at the Willmar Middle School in Willmar, Minnesota. We are both physical science teachers in 6th grade. Our mentor information, Dr. Thomas Prevost was instrumental in helping us gain knowledge and understand the dynamics of air traffic control systems, which we will be speaking about in the second half of the presentation. The research that they are conducting involves air traffic during the en route sectors. Once it leaves the TRACON section, gets up to a certain elevation, air traffic controllers will take the airplanes and guide them through their sectors individually. The simulations that were run in this particular program were geared towards human-in-the-loop interactions, meaning the simulation was designed not only to run data, but also to run human interaction and get the data analysis information from that. One of the aspects of the simulations were to take information comparisons from our current method of travel of air traffic control when aircraft follow a specific route compared to when aircraft follow a specific corridor. The requirements to fly in the corridor for the aircraft would be if they are equipped with certain technological pieces of machinery, which I'll explain later on in the presentation. They have to be able to fly at a certain altitude and a certain speed. And so the simulations compared aircraft that were equipped versus not equipped, flying both in the corridor and out of the corridor. So there was a combination of 4 different scenarios that were incorporated into the simulation, and we'll get back to that more in just a little while.
This is the start of about a 12-day lesson unit, as you might say. And during this time, we're going to learn about the history of flight, the forces that act on an aircraft, how aircraft control components and aircraft movement are related. We're then going to look at designing an aircraft and actually taking that design and building a model for simulation for or from it. We'll construct it and test flight the model. We'll learn about the dynamics and engineering of air traffic control systems and participate in air traffic control simulation and human interaction activities.
Okay, so this is geared towards 6th grade physical science students. The prerequisites would be that earlier in the year we would have already taught them about Newton's laws of motion. They would have some knowledge of simple and complex machines, which is also part of the curriculum that we use. And to understand the scientific processes of design and experimentation, and I have a diagram here that explains that. This is found in your Eclipse packets. Design process: identify the problem, identify criteria and constraints, brainstorm possible solutions. Select a design, build a model or prototype, test the model and evaluate, refine the design as needed, and when you come to a design that's complete, share the solution. Many times as you run simulations, you find that the more questions you answer, the more questions you tend to ask, and the simulations never end. So, let's continue on. The learning objectives. We're going to understand the history of flight. This is important because as 6th grade students, there's limited background knowledge of science, there's limited background knowledge of the design process, there's little background knowledge of what it takes to take an idea from the drawing board through fruition to creating a complete design. The students will be able to describe the forces of flight. Students will understand the 3 main types of aircraft movement and what components of the aircraft are responsible for that movement. And of course, as you guys know from being in this workshop for the last 2 weeks, that involves the roll, the pitch, and the yaw. We're going to introduce students to the concepts of aircraft design, aerodynamics, performance, stability and control, structures, propulsion, manufacturing, and we're going to encourage them to use their technical knowledge toward engineering design. So basically the students are going to use their knowledge of the design process, use what they are learning about aircraft control to design their own aircraft on blueprints, on paper first, then to design a prototype or a model, take it out and test it, do some simulations both on the computer and in person, actually run some test flights, make some modifications, redesign, and retest. Students will construct a glider using principles of flight and assess glider performances based on the test flights. Students will describe current and future air traffic control systems. Once they've built the aircraft, then we're going to talk to them about how do we actually monitor air traffic as an airplane takes off from the ground, as it flies across the country or flies around the neighborhood, dusting crops wherever it goes, and then back down to the ground again. So the students will be able to demonstrate the knowledge of air traffic control through computer simulation and through human interactive activities. Procedures. Oops. On day 1, we're going to use the Thunderbird clip to get some attention. I noticed everybody was looking at the screen, cool music, cool visual. And that's going to, we're going to start with the KWL chart, which is the what do you know, what do you want to know, what do you want to learn. We're going to keep that handy and we're going to refer back to it throughout the lesson. We'll start with the history of flight presentation, which I'll be getting to momentarily. We're going to use a PDF file found on the NASA website. It's by the Wright brothers, and I do have the citation later on I can share with you. Day 2 will be the forces on the aircraft. We're going to use the Exploring Aeronautics DVD, which we all got in our packets this week, or last week rather, to demonstrate the aircraft controls and forces on the aircraft. We're going to go from there into designing our own aircraft, which will take a couple days. During that time, we'll be able to test it. We've got a couple other video clips to give them some ideas to help them think outside of the box. And not just draw something that's already existing, but to create something new of their own design. They'll build a prototype of it and test it. And after testing it, then we'll go back and revise it as needed or refine it. Then we'll move into the air traffic control. We have some simulations, we have some activities. We're going to have some worksheets that go along with these things so they can track their data. They can record what's working and what's not. Got a few videos in amongst here as well, and a really cool simulation, which you've all seen as well, using Smart Skies. As a summary, we've got, going to refer back to the KWL chart again, see what we've learned, see if we've covered everything that they wanted to learn. And then to finish off, we've got multimedia presentations on Kia. Kia is a website that we've been using in Willmar, and Kia is an online service that you can access anywhere you have internet access. We do have a mobile computer lab that has, what 25, 30, 34 computers. So we roll that in the classroom so each student does get their own computer for these types of simulations. So we have a couple of games created, we have a couple of review activities, and we've got a formal assessment at the very end. So let's get started on the presentation. Aviation history, just kind of a fun picture I found. That's Otto. I'm not sure how to pronounce that last name. Anybody can help me out? William. Okay. One of the German inventor that unfortunately died trying to fly one of his gliders, but was instrumental in creating some of the data and some of the designs that led to further refinement and led to some aircraft design. This is a fun quote that I found by the Wright brothers. Could you read that for us, please?
I would hardly think today of making my first flight on a strange machine in a 27-mile wind. I look with amazement upon our audacity in attempting flights with a new and untried machine under such circumstances. Yet faith in our calculation of the design of the first machine, based upon our tables of air pressures, secured by months of careful laboratory work and confidence in our system of control, and convinced us that the machine was capable of lifting and maintaining itself in the air. Orville Wright from How We Made the First Plane.
Okay, so that's a diagram of one of their first kites, the first wing design that they came up with. They kind of figured it out because they were sitting there in their bicycle shop. I'm sure many of you know the Wright brothers' history a little bit, so I'm not going to go into detail about that right now in the interest of time. They were twisting a bicycle box, and that's kind of how they got the idea for how the first wing could move a little bit. And again, for 6th grade, we do cover much more information than we're going to cover today, but in the interest of time, and since this is a 12-day unit, we're trying to preview it in 45 minutes or less. We're going to just kind of skip over this because I know that all of you know about this, but we're going to cover some of the history of Wilbur and Orville. We're going to talk about the original concept. They used a few different things, information from other engineers, other designers, other creators. They got some information from the museum, the Aeronautic Institute, and they also took some observations just from nature. They watched birds, they watched how the wings move, they watched how the tail moves. They used some of that information to help them in later designs. So they took the idea of a kite or a glider, thought that they could possibly make it heavy or sturdy enough to support a human. There's their first glider that they actually flew. Obviously, after they take it out, fly it, they're going to make some revision. That's all part of the design process. Their problem was that they wanted to fly. The criteria and constraints were it's difficult to get a body off the ground because there's forces acting upon it. They figured out what forces they could overcome and how to do it to a certain extent. Every glider they made, they revised. They went through the building the prototype, testing and evaluating, and refining the process over and over and over again. And that's what we really encourage with our kids. Ask a lot of questions. When you ask a question, research that question, test that question, and come up with some idea, come up with something to solve the problem. So each one of these designs was improved dramatically. After the second major design, they kind of went back to the drawing board because they weren't achieving quite the lift that they were hoping for. They built their own wind tunnel. Okay, these were a couple guys, I don't know if you guys know this, but they didn't go to college or anything. They were a couple guys who were just very creative, and their spirit of inquiry was just fostered by their parents, by their community. They were encouraged to chase down their dreams and do whatever they wanted to. So there's a couple guys that just are really creative and are willing to follow that creativity, ask a lot of questions, higher level thinking skills. Pretty impressive that they came up with a wind tunnel to be able to test some of their aircraft design and wing design. So of course, as they move along, they progress, they build better designs, they get more control. They get to the point where they figured out by watching birds primarily and by testing their designs of the wind tunnel, of course, that they need to be able to control the airplane as it tilts this way to this way. They refer to that as, what's this way?
Roll.
Okay. They also decided that they need to be able to control it up and down because they don't want to go up too fast and they don't want to go down too fast. And that's referred to as the ditch. And they also decided that they need to be able to turn this way to this way, which is called yaw. And so they created controls on the aircraft that would help them in maintaining these movements. Not perfectly, of course, but every model gets better. by 1903, they decided that they want to be able to sustain flight longer, so they wanted to put an engine on their aircraft. Of course, this opened up a whole new can of questions, added a lot of weight to the aircraft. Nobody out there could build them a motor that was powerful enough and light enough, so of course they just went back to the bicycle shop and built their own. Then they had issues with, they had to make the plane larger. They had to increase the lifting capability to combat the extra weight. They had to increase the thrust with the engines to be able to stay in flight longer and combat the drag, or oppose the drag rather. And so adding power to their flight created a whole new set of design issues. So like I mentioned earlier, a lot of times when you test and evaluate and you refine your design, it just adds more questions to the equation. It makes the process take longer, but it's great, it's fun, that's what being creative is all about. And that's what we try to encourage in the classroom. So new design, more improvements. The launching derrick on your right that you're looking at was a thing that they designed, had a track going across the field. They would set the aircraft on the track. Their aircraft wasn't able to provide enough thrust on its own, so they actually would hoist a very large weight to the top of the launching derrick here. And I'm not sure exactly if the aircraft was just far enough away that they pulled it, or if they had some sort of a pulley system to pull it the opposite direction. I'm not sure, but they used this. They would drop the weight to get the aircraft moving fast enough to generate enough lift to get off the ground.
What we're looking at here is the 4 forces that are required for flight, which are lift, weight, thrust, and drag. The first one we're going to look at today is weight. Real briefly, weight is a force. It's a force of traction between an object, could be you, in this case here it's the airplane, and the earth. The more mass it has, the more weight it's going to be, and so forth. In an airplane, the weight is trying to be evenly distributed. It goes around a center point of gravity, as they might call it. And during flight, fuel is used up, so there's a constant change to the center of gravity. So it's up to the pilot to try to adjust for the change of center of gravity. Contradicting the force of weight is lift, which is what allows the object to fly. Aircraft wings and the shape of the wing, as well as the shape of the aircraft, also contribute to how much lift there is. Basically, lift comes from the idea that as the aircraft is moving forward, there is a different shape to the wing, and at the top, the air is not moving as quickly as along the bottom, so therefore there's a greater force pushing up than there is pushing down, and allows the aircraft to rise into the air. As the aircraft is moving through the air, it's coming in contact with air molecules. That produces air resistance, also referred to as drag. It is working against the movement of the aircraft. The shape of the wing, the aircraft shape, as well as the air composition and the velocity all factor into how much drag the airplane is having to deal with. And finally, thrust, which is working against drag, is the actual push, as you might say, that keeps the air moving, allows for lift to occur. What can affect the amount of thrust is the number of engines, how big the engine is, and the throttle control. We have a short video here showing what the Wright brothers were working against. There we go.
Calculated to overcome the weight of our new aircraft.
Thrust and weight. You know, those are two of the forces in flight. Any motion through the air is the result of forces. Norval and I had to take into account all 4 forces in flight in order to build our airplane. Let's talk about those 4 forces.
That's a good idea. Let's start with the easiest force to understand. That's weight. Everything on Earth has weight because of gravitational attraction. This includes aircraft. They're always being pulled down towards the center of the Earth.
That's right, Ord. And to overcome weight, all aircraft have to produce lift. Lift is a force that counteracts weight, and it's generated by the forward motion of the aircraft through the air, creating an aerodynamic force. The shape of the aircraft, in particular, the shape of the wings and the velocity of the aircraft determine the amount of lift. The greater the speed, the greater the lift. But unfortunately, there's another aerodynamic force involved, and that's drag. Drag is the resistance of the aircraft to moving through the air, and it's also related to the shape of the aircraft, the stickiness of the air, and it's a big function of speed. The greater the speed, the greater the drag.
When we flew, we actually laid down on the wings to reduce the amount of drag. To overcome drag, we need another force, and that's thrust. Thrust is created by the propulsion system to drive the plane forward. The amount of thrust depends on the size and number of engines, as well as the way that their power acts on the surrounding air. We use propellers to drive our aircraft through the air. Most planes today, however, will use jet engines to provide thrust.
The motion of any airplane through the air depends on the relative strength and the direction of these four forces. If the forces are all balanced, the aircraft cruises at a constant velocity.
However, if there is any unbalanced force, the aircraft will move in the direction of that force. The largest force controls which way the aircraft moves.
Yeah, that sounds pretty good. But let's go try it.
Okay.
I've got an idea.
Oh, do you? Tell me.
Yeah, I think it would couple up this one.
Okay, now we're going to move into aircraft controls. As you remember from the procedures, this would be probably the third day of the unit. Aircraft controls. What parts of the airplane actually did control how it turned? Well, by looking at the way the air would flow across the airplane, you can probably tell that when the rudder turns from left to right, the air that's flowing past it would turn it. Likewise, the roll was controlled by the wings or the ailerons in the front, which on more current aircraft you would notice are probably located on the wing section. And the pitch was controlled by the elevators, which are also part of this contraption on the original flyer that moved up and down as well. Nowadays there is the boom going out the back of the aircraft more often than not, and that's where the elevators are located. So this is just a summary of what I just explained, and we're going to take a look at just a real quick simulation where you can actually see this in action. Okay, here are the ailerons that are located on this aircraft on the back of the wing. You can tell by the diagram that when the aircraft turns the ailerons, it responds according to how the air flows past them. That's how the aircraft is able to control the roll. Okay, let's go back. Let's take a look at the elevators. Elevators would control the pitch of the airplane. If it goes up or down, they would use the elevators. And I think if you click on this picture, it'll spin it around, right? Well, you can see how the tail section, the elevators are moving up and down, again reacting to the airflow, tipping the pitch of the plane up and down. And finally, we have the rudder. The rudder is used to control the yaw, which is the back and forth movement of the airplane, oftentimes used in coordination with the other controls to make more complex turns. That's a basic movement of an aircraft. Now, the reason why we use two computers to do this is because this CD takes a long time to get booted up, and you can't minimize it, so in case you're wondering. Okay, so now that we've learned about the history of flight, we've learned about the forces that act on the aircraft, and we've learned how we control the aircraft to oppose these forces or to work with these forces, as the case may be. We're going to start our engineering project.
This project is something that we actually did use before coming to NASA last year to a smaller extent. The idea is to take the students' creativity, and that's key, and try to put something to paper and hopefully into three-dimensional model. Very interesting quote here. To invent an airplane is nothing, but to build one is something, but to fly is everything. So that's kind of summarizes this whole project up. So this idea is, now we've looked at human travel, how an airplane works, we saw some videos on it, but now take our ingenuity, as you might say, and apply it to the paper, and try to come up with a design that might lead to future developments. The criteria that I give the students is I give them usually about one 11 by 17 sheet of paper, which is about the size of one of these right here, and it's white, and I say, okay, you know, if you could design an airplane of your own, forget what you've seen before, but if you could design the perfect airplane, what would it be like? And I have them draw what their airplane would look like on this. They need to show two different views. The top view, like as if a bird was flying over the top looking down, and also a side view, as if you're walking beside it, what would you see as well? They have to explain the different types of the aircraft, you know, the ailerons and the rudders and so forth. And they need to think about the fuel. Most of the time now with jets, you have, you know, aviation fuel and so forth, jet fuel. They need to be responsible for marking all the different parts, and then if they have a special type aircraft, what's the different special parts to it. Once they have, and that usually takes a couple days, 2 to 3 days depending on how things are going. Once they have their drawing taken care of, and they have to have everything drawn out on their blueprint, they have to measure the dimensions of the aircraft and so forth and have it written down like a normal blueprint would have. Then the next step is to actually build the aircraft. So what I do then is we get cardstock, heavier paper, and I give them a couple pieces of it, and they take their drawing or their idea and transfer it to the cardstock, and eventually then cut it out, kind of like what we did with the jet airplane activity from last week and so on, and construct it, tape, glue, stuff like that. And we work on it in a couple days.
I did something.
That'll wake you up. That's why you got that music.
And we're calling the classroom too. We have the volume cranked up. Serve our neighbors.
I wish that I could fly into the sky so very high, just like a dragonfly. I fly above the trees, over the seas, and on the breeze, to anywhere I please. Oh, I want to get away. I will fly away. Yeah, yeah, yeah. I want to get away. I will fly away. Yeah, yeah, yeah. Let's go and see the stars, the Milky Way, or even Mars, where they could just be ours. Let's wait into the sun, let's just spin and fly.
Okay, in the interest of time, we're going to cut that one short, but you get the idea. We play this video as they're starting their design process to get them to think outside the box. Don't just draw a typical airplane. Draw something that you think would be unique, but be able to explain the purpose. We would stop this slide as it goes, talk about where the rudders are, where the ailerons are, different things like that. As you notice that some of the wings were up high, some were down low, some have propellers in the back, some in the front. Why would these have different placements for these things? What's the purpose of it? And so when they design their own aircraft, they have to kind of be able to explain why they created that the aircraft the way they did. And then just one more kind of a cool one. Thinking futuristic now. probably spilled his coffee on it.
I like it.
When my kids saw this video, it just really spurred them to try doing something unique, showing that it doesn't have to be, you know, the same old typical airplane, that they can try new ideas. And that really brought up some really interesting things when we started taking their designs and building the actual three-dimensional model and so forth. Like I said, they were using cardboard, not cardboard stock, but card stock, as you might say. And it takes, you know, some kids 2, 3, possibly 4 days on some of their complex designs to build it and so forth. But once they got their model built, then we go up and we try that in a simulated airspace and see how well it flies. They try to predict what happened and then try to then make adjustments so that the craft does what it wants, what they want to do.
You know, we take the basic design, have them throw it down the hallway and say, hey, how did that fly? What can we do to control it? What can we do to make it better? Should we add some more weight? Is it off balance? How do we change that? What can we do to make it fly straighter if that's what you're trying to achieve? If you're not, if you wanted to curve it, what controls could you add? Could you add some elevators in the back to control the pitch? Could you add some ailerons somewhere along the side to control the roll? What can you do to change your aircraft design to improve it and to constantly redesign it, refine it, test it, and then keep working with it? Okay, so that moves us into the point where we're going to talk about air traffic control. Now that the kids have learned the history of flight, the forces that act on an airplane, how to control an aircraft, and they have actually built their own aircraft, now they have to figure out how do we take the aircraft off the ground, fly it safely, and then land it again. So we're going to take a look at an air traffic control real quick video.
Again, we use a lot of these because, again, 6th graders are very easily distracted. So we're showing different videos today, which there might be only 1 or 2 every couple of days we show.
During peak air travel times in the United States, there are about 5,000 airplanes in the sky every hour, which is about 50,000 aircraft operating in our skies every day. From the time the plane pushes back from the gate until it arrives at the gate of its final destination, it is being handled by air traffic controllers. These controllers must coordinate the movements of thousands of aircraft, keep them at safe distances from each other, and direct them during takeoff and landing from airports. Air traffic controllers are also responsible for directing aircraft around bad weather and ensuring that traffic flows with minimal delay for both commercial and private aircraft. And I spoke with Gary Laura from NASA Ames to find out how it works.
An air traffic controller is primarily tasked with separating airplanes. However, they may provide other services such as traffic advisories, weather information, and other status types of information in our airspace.
What are some of the tools used by air traffic controllers?
The primary tool used by controllers for separation services is called radar, which stands for radio detection ranging. Essentially what happens is from an antenna, a radio beam...
In the interest of time, and since we've all seen about 15 of these videos this week, I'm just going to stop it there. But at this point, the kids have been in class now. This is probably about the 9th to 10th day. And so this is about the 3rd or 4th video that they've seen, and they've done at least 2 activities so far.